Hello students, welcome back. Now let's talk about some quadratic inequalities. Quadratic inequalities, and as a matter of fact, all kinds of inequalities in polynomials or rational functions are all considered highly important in STEM algebra. In business algebra, on the other hand, we do not emphasize inequalities a lot for some strange reason that I do not understand, because they come back in business calculus and then students struggle there because they didn't really cover it very well in business algebra. It's a kind of vicious cycle, so I'll try to break it at least to a certain degree by trying to cover at least some degree of quadratic inequalities. So no higher division or cubic or anything but quadratic. Alright, here's a motivating example. Solve the given quadratic inequality. How do you do that? I see this kind of answer a lot. X plus 5, x minus 1. And then you see you have blue and you have red. So blue, x plus 5 is less than 0, or so that's blue, and that's red. And then from the blue inequality, I get blue answer. From red inequality, I get the red answer. And you just earned automatic 0. This is a 0 credit because the logic is wrong, the answer is wrong, everything is wrong. It shows that you have no understanding about inequality. If this had been an equation, yes, it works. Factor, and either blue is 0 or red is 0, so you get either blue solution or red solution. Quadratic equations have, in general, 2 solutions, and we have blue and red, and that's it. Now, how about inequality? That doesn't work. By the way, let's discuss why this works for equations. In the second line, blue times red is equal to 0. Therefore, either blue is 0 or red is 0. There's no way I'm going to get 0 by multiplying 2 non-zero numbers. That's why we can reduce either blue is 0 or red is 0 like this, so that we get blue solution and red solution. For inequalities, on the other hand, things do not work like this, even though a lot of students do exactly the same thing as they've been doing for equations. Blue times red is less than 0, negative. That means we have 2 opposite signs. If blue is 0, then red has to be greater than 0, or you get something like this. Blue is greater than 0 and red is less than 0, so that you get 2 opposite signs. Blue is negative and red is positive, or blue is positive and red is positive. Consequently, the conclusion will get a heck of a lot more complicated as well. You can do it like this, but that's not the approach I'm going to take. I'll tell you a little bit more practical method. In any case, please remember that this kind of solution is completely wrong. It's automatic 0 credit. Do not work like equations, because equations and inequalities are fundamentally different. They're related, but they're different. How do you do it right? Well, let's discuss only the easiest method, because this is just business algebra, not STEM algebra. First, let's come back to the very first problem that we studied. And a graph method associated to a graph of the quadratic function y equals to x squared plus 4x minus 5. After being factored like this y has to be less than 0. Okay, we have quadratic function y equals x squared plus 4x minus 5, and this one here is the intercept form. Now, y is less than 0. What portion of the graph has y-coordinate less than 0, red or blue? Above the x-axis or below the x-axis? Which y-coordinate is less than 0? It's the red region. And for that, x value has to be between -5 and +1, or in other words, the interval -5 to +1. Make sense? Always couple with a graph. How do you know this point and that point are -5 and +1 precisely? You can solve through equation. You factored, so that's it. You got the intercept form. You got the intercept, x-intercept, -5 and +1. But less than 0, greater than 0, less than 0, red portion, greater than 0, blue portion. Here's another example problem. So how does that work? X squared minus 2x, flip over, minus 3x, plus 6 is greater than 0, right? If I flip everything to the left-hand side. So combine these two like terms, looks like that's what you get. Alright, if you factor, what do you get? X minus 2, x minus 3. That's what you're going to get. Alright, in the general form, y equals to x squared minus 5x plus 6. That's greater than 0. Or in the intercept form, the same thing can be rewritten like this. Now, which portion do I have to look at? Above the x-axis or below the x-axis? Above or below? Which one is it this time? This time, we have to look at above the x-axis because y-coordinate is greater than 0. Previously, y-coordinate is less than 0, so we looked at the red part where y-coordinate is less than 0, so that the graph is below the x-axis. Now, y is greater than 0, so we have to look at above the x-axis, this blue curve and that blue curve. We have two curve pieces, so you have to expect two intervals. X is less than 2 or x is greater than 3. Or in other words, the interval expression -infinity to 2 union 3 to +infinity. This one union that one. In general, if quadratic expression is greater than 0, you'll have to do this or that. Less than 0, you're going to get double inequality. Always couple with a picture. Let's see, do we have enough time for another problem? Okay, so how does that work? Left hand side is gonna be, let's foil it, 21x, and outside 12x squared, inside 14, last 8x, and that's greater than or equal to 6x plus 4. Did I do this right? Okay, let me flip everything to the right hand side, but before that let's do some simplification. -12x squared plus 21 minus 8, so that is 13x plus 14 is greater than or equal to 6x plus 4. Let's see, just combined this. Okay, let's flip everything to the right hand side because I cannot think straight if the leading coefficient is negative. So move everything to the right, 12x squared now, and then this one negative 13x minus 14 and 6x plus 4 were there before. Or if you're not comfortable with this, like this, flip everything to the right hand side. So what do we have here? 12x squared and then negative 13 plus 6, so negative 7x, and negative 14 positive 4, negative 10. So less than or equal to 0. Yeah, I used to have this one here left, but I can move it like this. Can you factor this? Do you have enough time? Okay, all right. It's been a long time since I helped you with this. So first 12, last negative 10, and then that's negative 120, and a factor of negative 120 adding up to negative 7. What are those? Is that it? 15 times 8? Well, we need negative 120, so we need two opposite signs. Which one is negative, which one is positive? This is negative 7, so negative 15, positive 8. That'll do. Okay, and then let's fill everything up. So let's see, this should be 3 times 5, 3 times negative 5, and then this should be 4 times 2. Does everything look good? And then cross multiply, 3x plus 2, 4x minus 5 is less than or equal to 0. So what do we get? We get the x-intercept, negative 2/3. So this one here will give me negative 2/3. That one here will give me positive 5/4. And I did this without even drawing the graph because, you know, this quadratic expression less than or equal to 0. So we have a quadratic curve concave up, and then down below we have an interval that goes below the x-axis. So I did that, but it's going to be, of course, better if you draw the picture. Let's see, what did I do here? Yeah. After getting all those manipulation and factorization, look at the graph. Y equals to 12x squared minus 7x minus 10, this thing. Here's a graph. And less than or equal to 0. So you're looking for this interval here. And what is this value and what is that value precisely? Just by inspection, it's hard to tell. So you have to go back to this factorization and find out the x-intercept by setting this equal to 0. Turns out negative 2/3 and 5/4. So we get this interval, negative 2/3 to 5/4. Why bracket? That's because we started from greater than or equal to, semi-inequality. So some of the hard problems go like this. And this problem is going to be almost equally as hard. I'll leave the details to students.